Recursion in programming refers to a method where the solution to a problem depends on solutions to smaller instances of the same problem. It is a technique often used in computer science for solving problems that can be broken down into simpler subproblems of the same type. The use of recursion typically involves a function calling itself in order to solve these subproblems. To better understand recursion, let's consider a metaphor. Imagine a set of nested dolls, where each doll contains a smaller doll inside. Recursion is like opening each doll to find a smaller one, until you reach the smallest, simplest doll. In programming, this smallest doll represents the base case, the condition that stops the recursion. Typically, a recursive function has two main parts. One, base case. This is the scenario where the problem can be solved without further recursion. It's critical because it prevents the function from running indefinitely. For example, in computing the factorial of a number, the base case might be factorial of 1 is 1. 2. Recursive case. This is where the function solves a part of the problem and calls itself with a smaller or simpler input, moving closer to the base case. Here's a simple example in Python, calculating the factorial of a number using recursion. Python def factorial, and if n equals 1, return 1 base case else. Return n asterisk factorial n 1 recursive case. In the example, when factorial 5 is executed, it proceeds as 5 asterisk factorial 4 for asterisk factorial 3, all the way down to 1. When it reaches factorial 1, the base case is triggered, and the recursion starts to resolve, returning the result. It's vital to design recursion carefully to avoid infinite recursion, which can lead to a Stack Overflow error.